The first talk, as you see, will be delivered by Przemysław. Przemysław will be talking about the big bad data, which I'm actually covering. He's former employee of Hadapt, which was recently acquired by Teradata, and now he's working at Ocado. So big applause for Przemek.
So thank you. Today I want to talk you a little, tell you a little bit about the big bad data, or how to deal with data sources, or rather how to not deal with them. So first I would like to give you a quick introduction to Ocado, to the company I'm working at right now. Then I will tell you how we did try to approach big data and why we ended up with bad data actually, and then what we did to make things better, how did we try to improve things, and also if we have time left I will try to show you a short demo of some part of our product that we developed in-house. So let's go to Ocado. Okay, so maybe not many of you have heard, but Ocado is the world's largest online grocery retailer. And the reason why you may never heard about it is because it operates only in the UK right now. So it reaches over 70% of households in the UK. We deliver over 150,000 orders every week, which is 1.1 million items every day. So it's quite a big amount of items. And here's a picture from our customer fulfillment center. So it's basically a very big warehouse, semi-automated. So here you can see the lines and the red boxes with the items in them. They are just going through the warehouse. And as you can imagine, we gather all kind of metrics from this warehouse, logs from the machines. So there's a really huge amount of data that comes from the warehouse. But that's not all, because there is also, of course, the web shop and the mobile application where you can buy stuff, and we gather just everything. We gather click streams, checkout events, new customers registering. So basically, virtually everything. And also we gather logs from backend services that support the system. So we really have quite huge amount of data. And traditionally, as you'll see in a minute, we had this layer on the left. So all those logs, all the data was pushed into the traditional databases like Oracle, like Greenplum, and we were trying to do some analytics in those databases. But unfortunately, the amount of data grew so large that we couldn't handle it with those databases anymore. And that's where the big data team came in. So we started working on big data in Ocado last year, October, and we went into production in March this year. And this is how our architecture looked at the very beginning. So we would have export jobs, because the data would still go to those traditional databases, because of course we had a lot of analytics done there. We couldn't just move everything to our platform. So all the data was there, and what we did is we did export jobs that run every night and takes the data from those databases and put them into Google Cloud Storage. So for those who don't know what GCS is, it's basically a distributed file system, something like S3, but from Google. And also we had some data that was uploaded by users manually. This is why we have the smiley face in the left bottom corner. And then when we got this data, we would spin up a compute cluster, which would take all this raw data and transform it into some Hadoop-friendly format. In our case, this is ORC, and then upload it back to Google Cloud Storage. Some of the data would also go into Google BigQuery. This is on the right bottom corner. So Google BigQuery is basically SQL as a service delivered by Google. So it's a tool where you put all your data in tables, and then you can just spin up. You can send a SQL query, and you'll get results really quickly, because Google BigQuery is, I don't want to advertise Google here, but it's really a beast. So of course it has fluctuation in performance, but we saw it perform SQL query on 3.3 terabytes of data in 17 seconds. So it's, for us, it was really impressive, something we couldn't achieve with Spark or Hadoop, which we have on those clusters. So yeah, so some data will go from compute clusters to BigQuery, and then analysts, business, people from business side can go in and just put SQL queries. But of course, SQL is not everything. We need also machine learning, which cannot be done in BigQuery. So we have user clusters. So user can come in. It will go to the cluster manager. This is the tool that I want to show you at the end of this presentation, which manages clusters in the cloud. So the user comes in, says, OK, I want a cluster in the cloud. The cluster gets deployed, and then it fetches data from Google Cloud Storage, and you can perform some computations on it. So this is how it started. And at first, we were very pleased with how it looks like. However, when the time passed by, some problems have occurred. So the first problem was that we got raw data in various data formats. So we got JSON, we got CSV, the files were uncompressed or compressed, or maybe they were just byte blobs of data, or they were nested structures, so lots of various data formats. Plus the data had different behavior, because some of the data was incremental, so we just took the new data and appended to the old data. Some of those were snapshots, when you actually snapshot the database and you need to replace the old data with the new one. Or the deltas, when you actually need to merge both of those. So as you can imagine, we had a lot of code to handle this, lots of corner cases. It was really a mess. Plus we had the corrupted data, because sometimes things went wrong and we got corrupted files on Google Storage, or empty files, or with the content that we did not expect, or schema changes. So I can actually give you an example. We had an export job that does just select star from table and just put it into Google Cloud Storage, and then someone upgraded the database, and then the order of columns has swapped. So yeah, it was kind of unexpected. So as you remember, we have this overnight job that takes raw data, transform it to ORC files. So it would fail because of those. It had failed because of those problems. Plus, the next problem is that data exports may be delayed. So you can have DB downtime, you can have network issues, or there may be human error. And then, as you remember, we had this job that runs every night. So normally you would have 1 day delay in your data, but when those problems occurred, the data was available for analytics even later. So let's go on. So we had also missing data. So this is a picture we got from our analysts, and they said, hey, look at this. There's something wrong with page views table. So the number of records in page views table dropped suddenly, and we didn't know this before they told us that something wrong with it. And so you can see this went for like half a month, this drop in data, and this was because of some server failures. Okay, let's continue. So how to do real-time analytics in such architecture? The answer is you don't. You just can't do it. Forget it. Plus, ORC is not a dream solution, because ORC, this Hadoop-friendly format, is actually byte blobs, so you cannot just take a piece of it, give it to analysts and say, oh, okay, I can run some custom Python job on this and see what this data means. So you cannot do this. Plus this overnight transform that we had, row events going in, row ORC files going out, it's the next point of failure when something can go wrong. Plus there is a data duplication because we have row plus ORC data. And the last thing I want to mention is that people started to think we own the data. Like they would be coming to us, hey, say to me, tell me what this data means. What is the schema of this data or whatever, but we didn't really know this because we were just transforming the data and putting it in some other place. We were not generating it. So at the end, people get frustrated. So we as a big data team are frustrated because we spend a lot of time on monitoring, fixing bugs. The code becomes complex. It's really hard to handle all corner cases. And our confidence in platform stability really dropped down. And analytics are also frustrated for two reasons. First is that they have a long latency before the data is produced, from the point of time when the data is produced and the point of time when this data is available for them to analyze. And also that the data is just unreliable, as we saw before. So we said to us, we can't go like this anymore. We have to get back to the board and figure something out. So what we need, we had problems with data formats, so we thought that we would like to unify this, and we chose JSON as input data format for a few reasons. First, it's very elastic, so you can just basically do whatever you want with it. It's well known, it's easy to produce, easy to parse. It's human readable also, and all the columns, all the schema is just explicitly given to you in the data that you get in JSON format. Next thing that we thought of is that lots of problems that we had was caused by this export from database to our system. So we thought, why do we need that at all? So let's make all applications make all applications send data directly to us. So what we did is we introduced a distributed queue. In our case, this is Kinesis, but it's the same as if you know Kafka or RabbitMQ maybe. So this is just a distributed queue. So we push all the data to the queue, and then we take the data out of this queue. Plus, we have data validation monitoring because we wanted data to be well described so that no one will come to us and say what this data means. We wanted it to be well described from the beginning. And the validation should happen early, so if anything is wrong with the data or the volume of data drops suddenly, we want alerts on those things. Plus, how to solve the problem that data must be ready for queries early. So we thought that we will push all the data to the BigQuery first. No transform job. We'll just stream it to BigQuery. And so this is like the big picture view of how it looks like right now. So we have this data coming from the left, from the input stream, which is the Kinesis that I told you just a minute ago. And there is event processor. This is distributed tool that we wrote, which takes data from this queue, validates it based upon metadata it gets from event registry, and also decides what to do with it, whether to send it to the cloud or to the data storage, which will be BigQuery, as you'll see in the next slide. Okay, so here comes a row event, and it goes to event processor. Then event processor will ask event registry, what is this event? And when it has this information, it can either say it's invalid, so it can push it to this lower, to this thing at the bottom of the picture, and then when we decide that we want to replay those items, then they can be pushed back to Kinesis, to the distributed queue, and then they can go through event processor once again. And if the event is valid, it will go to BigQuery. And from BigQuery, it's immediately available for all the analysts. So they can use BigQuery Web UI, or they can use Tableau connector or Excel connector, whatever. There are lots of connectors for BigQuery. And of course, sometimes we will export data from BigQuery to Google Cloud Storage to allow us to run batch jobs using Hadoop or Spark. And yeah, the next slide is actually about batch processing. So we have those clusters running in the cloud, and they get data either from BigQuery or Google Cloud Storage. And there's one more slide about real-time processing. So how it looks like, or how it will look like, because actually this is very new architecture, and we are just at the beginning of the process of pushing what we had before into this new architecture. So not all of this is yet implemented, so this is really brand new. So in case of real-time processing, you get a raw event, it goes to event processor, and then if the metadata says that, okay, I want this event, this piece of data to be available for real-time processing, it will go to the event queue, which is in the cloud, which is also a distributed queue. And then it will be fed to the clusters, which can later on save results on BigQuery or Google Cloud Storage. Okay, so how much time do I have?
Probably enough.
Probably enough, okay. Okay, so let me go to this video. So this is the cluster manager, the tool that we did to manage clusters in the cloud. So the reason I want to show you this is that we are thinking about open sourcing this piece of code. So you may actually hear from us soon about this, and we wanted to show you just a preview. So here you can see that we have one cluster running, that the quality is not the best, but we have one cluster running right now, and you can see what it cost is. You can stop it, you can see details, or you can go to the web interface of this cluster. And now let's go to see how you configured such clusters. We have some predefined configuration. We'll go to the Hadapt simple configuration, which is a very basic one. Okay, and here you define groups of instances. So you define what instance you want to start, what is the image, what is the machine type, how many of those machines are there. So here we have 2 workers and 1 master. We can go into details, and we can see that, yes, you can define a group name, you define machine type. Those are machines on Google Compute Engine, so this is Google's nomenclature. And you define what image should be used to set it up, and there are disks that you want to attach to those instances, and the tags about the network connections. So what's also important, you can specify what services do you want to have on those machines. And right now we have Zookeeper, Hadoop Master, Hadoop Slave, so not so many of them, but in the future we are planning to actually grow the database of those services, because lots of services are coupled together in Hadoop Master and Hadoop Slave, like Spark right now, and Yarn, and so on. Okay, so starting a cluster is very simple. You just choose a configuration you want, and then you just spin up a cluster. And you can see what will be its price per hour, number of CPUs, total disk space, total RAM, and then you just click create, and it will start in like 10 to 15 minutes. Okay, so it's starting. Okay, and you can see what instances are there. There are 3 instances, and 1 is still pending. 2 are already provisioning in Google Compute Engine. And there's only one thing else I want to show you, is that how the interface looks like is the Hue interface. It's developed by Cloudera. So when you click on the interface, you'll just get directed to it. And here, okay, takes some time. Okay, so this is the interface for all the Hadoop related services. So we can run a Hive query from here, or Impala, Pig, Spark, whatever you want. So you get this out of the box. When you start a cluster, you automatically get all of the services installed. You get this interface. You can do whatever you want. Okay, so I think that's mostly it. So, questions. So I have here 3 decks of planning poker cards. So for those of you who have questions, I'll give it to you. Okay. Oh, yep.
This architecture based on events for streaming all your data, is there any reason we are not using the term event sourcing here? Because essentially, this is it.
Yeah. So yes, this is it. But actually, we've never thought much about terminology. So it's yeah. Okay. Yeah, but you get the deck.
Why did you choose Google, not Amazon or other providers, or not your own cluster, for example?
So, so the first reason is why we did choose some cloud provider, is that we wanted to spin up all of this, like big data, really quickly, and setting up a cluster, it's really a pain. Like, and plus you need to buy hardware before you actually know how you will be using it, how much of it you need, and of course the updates on such clusters are very expensive, and we wanted to make changes very rapidly. So when we want to update, we just turn down the old cluster and we start a new one, and that's the update that we do. And why Google? Mostly because of this big query. Because this is really a big advantage of Google, something that is not present in Amazon. And yeah, and all other architectures followed up.
Cool. Thanks.
Okay, I've got one more.
Why wasn't it possible to use a Cloudera manager instead of creating your own cloud management tool?
So, as far as I know, Cloudera Manager works only on one cluster, right? Yeah. So, but we wanted many clusters to be spin up at the same time. Each one of those can have different configuration, can have different services, plus the services that are not available in Cloudera distribution, for example. So actually, we use part of it, of Cloudera Manager.
It even looks very, very similar.
Yes,
I think
yeah.
The interface, the skill is very similar to Cloudera.
Yes, but so the first thing is that we manage many clusters at the same time, and the second thing, what was the second reason? Roland, back me up on this.
I think we want to not only run Hadoop and Spark on these clusters.
Yeah, this is the mostly. Yeah, we want Cassandra, we want other services or custom-made jars and so on. This was mainly the reason. But we actually use part of Cloudera Manager because they have puppets to install everything. So we just stole their puppets and created our own UI. So this is for you. I don't have any cards left, but you can still ask questions. Yeah.
Okay, so how do you so that the investment on maintaining this infrastructure and building it is actually paying off?
Can you repeat the question?
Yes. How do you actually know that the investment on maintaining this...
the new architecture.
Well, the architecture and like investment that you did to create this actually is paying off?
So the answer is we don't know yet. We're just going there. We think this is a good way because we could only address those issues that we saw before. So all those issues that I just listed there, and the new architecture tries to solve them in some way. And of course, the new architecture will create the new problems, but we don't know yet what they will be. And yeah, for now, we kind of fully agree that this is the way we want to go.
Okay, but like the cost of maintaining this Google Cloud storage, is it high or is it?
So how much is it? It's like $26 per terabyte per month. So this is the exact cost of it. But because you're asking me why not store it internally, right? This is the question.
Well, generally, like how do you know that this was like a good investment?
Like the cloud platform. So right now, so right now the cost of the platform, we don't spend very high amount of money on this, and so if we take a look at the whole time when we started this platform up until now, I think we still paid not much more than what we would pay for bare bone hardware. Yeah, so we think this is cost effective because we don't. The next thing is that we don't need cluster running all the time. So this analysis happens once in a while. So we don't need those clusters to be running all the time. We don't need the hardware all the time. And this is what Google Cloud providers give us.
So currently, who are your clients? These are internal analysts.
Internal analysts, yes, exactly.
So do you think that in the coming future you will be able to provide at least some views of this data to your direct customers, paying customers? Or this is more or less still rather...
So it depends how you define a customer, because the customer who just buys in the shop,
I mean those who are buying systems for you, those who give you money.
Yes. So this is actually one, because I need to explain one thing, because except of us being a grocery retailer, we also sell technology. So last year we had last year we had a big deal with Morrisons, which is other grocery retailer in UK. They had no online service at all, so they just bought the whole solution from us. And yes, so they get everything.
So going a little bit deeper into details, you said at the beginning that you had problems with schema changes and like not knowing what data means, and then you created this schema storing service. How did you transition ownership of schemas from yourself to?
So right now it will look like until you tell us or register your data in our system, we won't gather it. So
if I register it and I change my schema?
So you need to change it in the registry also, because otherwise it will say it's invalid and will get dumped to this invalid event storage.
Okay.
And while preparing all of this, this investment on this cloud, do you have plans to sell the data like to someone who's interested in it?
Just the platform?
No, not the platform, but like that your analytics will produce like reports that is sold. Or you just do it for internal?
So right now it's fully for internal usage. So it runs also things like recommendation system for users that just want similar products, or promotions, or we do forecasting on what types of items we need to buy to store in a warehouse, because the grocery is kind of tricky business, because the time before, so the products get outdated really quickly, and plus you need big freezers to store them, and so we have forecasting how much we need to buy actually, and things like that. Okay, that's it. Thank you.